Hey everybody, in this next video lesson, I'm going to talk about predicting products of single displacement reactions. Now, unlike the last couple of examples of types of reactions that we've talked about, single displacement and the next one, double displacement, are much more complicated than, say, the combination and the decomposition and the combustion reactions that we've already covered. In single displacement reactions, we have to decide whether or not this reaction will happen or not. Unlike the other three that I just mentioned, those are assumed to always happen. A single displacement reaction may or may not happen, and I'm going to talk about how you decide that here today. First, what is a single displacement reaction? Well, we can identify a single displacement reaction when you have an element and an ionic compound reacting together. Look up here, we have a general form A plus BC, where A is a metal and BC is your ionic compound, usually the form of an aqueous solution. Now what happens is the A will come in, the metal will kick out the B or the metal ion from solution, where now B is by itself and now A is mixed with C in an aqueous solution as a product. Like I have in previous videos, I will now splice in a video that I've already recorded for another chemistry course, and at the end of this video I'm going to talk about what to do when A is a nonmetal and not a metal. The focus of a single displacement reaction are on two things, the metal and the cation. The metal and the cation are in a competition. The metal will replace the cation only if it's more reactive than the cation. So A, the metal, will replace B only if A is more reactive than B on the activity series. So you're looking at the metal compared to the cation. Now the activity series, as I pasted a picture here, is a thing that you will always be given, and it's used only for the single displacement reactions. And it's a list of metals and also hydrogen in order from most reactive to least reactive. So in other words, if the metal is above the cation on the activity series, the reaction will happen. A will replace something below it, B, as a cation. Now if the opposite is true, if A is lower on the list and B is higher on the list, then this reaction will not happen. I like to think of this as kind of like water flowing downhill. A metal will replace something below it, but not backwards. Just like water always flows downhill, metals always replace downhill. A metal will replace something underneath it. So here I've listed a handful of single displacement reactions, and I don't know whether or not they're going to react because I haven't checked the activity series, but I've posted a copy of the activity series on the right hand side. And so the first thing you do is determine whether or not the reaction will happen at all. Step 1, and this is clearly much more complicated than the previous predicting products types, so pay close attention, but you need to determine if the reaction will happen or not. So you take a look and you find the metal and the metal cation. Now the first one, aluminum's here and lead is down here, so this reaction will happen. And so I'm going to put this on the back burner. I'm just going to quickly say, yeah, this reaction will happen. I'm going to check the next one, and I'm just going to look for the ones that are no reactions. And so my next one, potassium with iron. So I find potassium, which is pretty high up on the list. Iron is pretty low on the list, down here, kind of in the middle. So this reaction, again, will happen. Finally, sodium. I'm going to find sodium, which is about 4 down, and lithium. Now, since sodium is trying to replace lithium, it will not because lithium is higher. So this reaction is a no reaction. So you can put NR as a predicting product because there is no product. NR, or no reaction, means this reaction will not proceed. So now that you've determined whether or not the reactions happen, the first two indeed do happen and the last one doesn't, we then do step 2, replace the cation with the metal. So I'm going to come in and I'm going to kick out lead. So lead's by itself, and now aluminum is going to be with chlorine. And for this next one, I'm going to kick out iron. So iron's by itself and potassium is with oxygen. The last two things I always do is check for diatomics and then balance charges. Now diatomic would only happen if the cation is hydrogen over here and gets replaced. Notice hydrogen's on the list. It's between lead and copper. So if this ionic substance is maybe an acid like HCl or HBr or some sort of acid where you have HCl, then the aluminum would replace the acid H, and then this substance right here, this thing that's alone or that got replaced, is hydrogen, and that's diatomic. So check diatomics, in this case only for hydrogen. Now the other thing that you need to do is you balance the charges. So look at your new aqueous solution, AlCl and Ko, and you need to make sure that those charges balance. And so aluminum is a +3 and chlorine's a -1, so I need AlCl3, and then I go in and erase the charges. And then K is a +1 and oxygen's a -2, and it's K2O, and then I go in and erase the charges. So in summary, it's important first to determine if the reaction even will happen or not, and that's the thing you do very first step. If you decided it does happen, replace the cation with the metal, and then check for diatomics and balanced charges. Now you have some experience taking a look at when A metal replaces B, a cation, in the two products that are formed, keeping in mind that sometimes this reaction might not happen. And I've mentioned the situations down here. If the metal is higher than the cation, then the reaction will happen, whereas if the metal is lower than the cation on the activity series, then the reaction will not happen. But what happens if the A in this case is a nonmetal and not a metal? Well, if A is a nonmetal, it's probably going to be a halogen, and your halogens are F2, Br2, Cl2, and I2. And if A is one of those, then it's going to replace the C in the ionic substance, because a nonmetal can only replace a nonmetal. And in that case, C gets kicked out, so C is by itself, and now B is with A, where A was the halogen that was originally by itself over here. Now there's one special case where a metal replaces a nonmetal, and that is when A is a metal and B is hydrogen in the form of an acid. So don't forget that A can replace a nonmetal if that first element is hydrogen. In that case, B would be kicked out, and that would be H2 gas, and the other two substances would mix together ionically in an aqueous solution. And so in a nonmetal replacing nonmetal situation, A kicks out C. There's an example down here. We've got fluorine in gallium bromide, and fluorine kicks bromine out, so now fluorine's with the gallium and bromine is with itself. Two things to remind yourself, as always. One of the products is going to be aqueous and ionic, and you need to make sure that you balance the charges. And gallium's a +3 charge and fluorine's a -1 charge, so the formula is GaF3. Now the other substance, the C in this case, is going to be a halogen, and halogens are always diatomic, so don't forget to put a little 2 here behind the bromine. Otherwise, you will not be able to balance this reaction successfully. In a final note, we're going to assume that if a nonmetal is replacing a nonmetal, like this example here on the right, then this reaction will always happen. So there is no activity series for nonmetals replacing nonmetals. Well, that takes care of this video lesson. Thanks for watching.